Good morning, guys. Welcome to another episode of Xah Talk Show. We are going to code Emacs Lisp today. So let me show you my keyboard first. So this is Ultimate Hacking Keyboard 80, UHK 80. I did a review about 2 weeks ago. Check on my YouTube. Okay, fantastic. Ultimate Hacking Keyboard. And today, we are just going to code Wolfram Language. Okay, so play at 1.5 speed. I command you. If you are here, say hi. Okay, we got like 2 people, 3 people say hi now. Okay, and we going to do Wolfram Language. So let's start. Now, Wolfram Language has been, you can download for free about 3 or 4 years ago. So let's start it. It is the most magnificent programming language, okay? A magnitude better than all existing languages. It's a high-level language. By default, you have 7,000 functions without loading any library, okay? And you can download it by just search for Xah Li, my name, Wolfram. Okay, so you can see Xah Li Wolfram Language tutorial, go there. And you can go there, download, and download at this link, Wolfram Language, Wolfram Research website. Okay, turn on JavaScript. The download is like 5 gigabytes. Okay, so because it's a artificial intelligence, covers everything. So download it for free and read my tutorial. This is in kind of comprehensive, tutorial for programmers. Okay, and so let's go to Wolfram Language for Programmers, download. Okay, and that's an introduction. Okay, and if you are coding, if you are an Emacs user, which is what you are looking at, the most powerful programmers editor, much more powerful than VS Code. You can download my Xah Wolfram Mode. Okay, the link is on my talk show page, or just search for Emacs Xah Wolfram Mode. That allows you to code Wolfram Language in Emacs. Hello, Blair Moore. Hi, Xah. Looking forward to this show. Thank you. So, introduce yourself. Like, where are you from? What country? Are you a student or are you something else? Okay, so today we're gonna let's go to desktop folder because I have these folders prepared. Now, if you have any questions about Wolfram Language, this is the time to ask me, okay? Ask me any questions about Wolfram Language. Now, let's see. Okay, now here is a list of things to do, I need to do. So as I do them, I'll explain them, okay? So let's begin, okay? Any questions, ask, okay? So Wolfram Language tuples. So you go to my Wolfram, basically today we're gonna demonstrate some list processing functions in Wolfram Language, okay? Wolfram Language for Programmers. Let's magnify this, and list, okay? So you got basics, print version, show function, help, find function by name, comment, and how to print, and string, and number, how to input numbers or hexadecimals, and boolean, true and false, how to test equality, and list. Okay, so list is what we want. Go to the list section, then go to list operations. Okay, there are so many. Like typically in Python or other programming languages, you have like 20 functions or methods on list. In Wolfram Language, you have like 100. Okay, without even loading any library. So what we want to go is list combinatorics. So let me show you guys what. So tuple, okay, let's do tuple. So copy that, go to the talk show page, and list operations. Let's paste the link there, show in browser. So combinatorics, okay. So let's okay, go there. Tuple. Let me just start to demo. Okay, so this tuple function, what it does is it returns all possible tuples of a given list. Okay, so let me show you. So what I want to do is A, B. Okay, run it. Cheers, red wine and juice. I'm a professor from Oklahoma. I have been using Emacs for 5 years. Oh my God, professor, thank you for being here. Yeah, so professor, that's great, because oftentimes my audience are students. So tuple AB, given a list of A and B, so you want all possible tuples. So you got AA, AB, BA, BB. Okay, so now let's say tuple AB, but three items per tuple. So you got all combinations, so you get more complex. So let's format it. Okay, so you get that. Now let's try tuple AB ABC. Okay, ABC, and let's just two. Okay, two tuple. So you get AA, AB, AC, BA, BB, BC, CA. So anyway, it's all combination, all possible combination of two things. Okay, so you see what I'm doing is I'm clarifying my tutorial. So this example I don't need anymore. Let's delete that. So 2 items and 3 tuple, we already got that. Okay, so now put it back. Syntax correct, showing browser. So we got our tuple function, return all possible n tuples. Okay, that's a demonstration. Now let's check my notes. Every hour or two, I walk around for half an hour with my Surface tablet, and I take notes. So these things I want to do. So these things are my notes. Then when I come back, sit down, and I code them. So this means, so what I'm doing here, these nodes means that I want to replace the 1, 2, 3, the source list, by symbols A, B, because if you use 1, 2, 3, it's more confusing, because if you use symbols, it's more clear. Now in Wolfram language, it's symbolic programming language, like Lisp. Okay, so everything is a symbol. So you can have AB and they'll just return, the value A or B or AB. You can have any name. In Python, for example, if you do this, you'll get, A is not defined, B is not defined, things like that. So, you can do this in Wolfram language because it's symbolic. And unlike Lisp, where you have to quote the symbols, if a symbol doesn't have a value, you have to quote it, like tick. But in Wolfram language, you don't have to, because when a symbol does not have a value, it's just the symbol itself. Okay, I think that's actually improvement. In fact, Wolfram language is much based on Lisp, basically Lisp and APL. That's the root of Wolfram language. Okay, so this example is done. So we want the example ABC2 done. Delete it. So next, with the okay, so return. So there's some wording issue. So dimension, return all possible array of dimension. Let's reword it. So let me show you where that is. So this is a tuple section. So we showed this input, but there are several variations of input. You can give it 2 lists. So this will effectively do Cartesian product. Okay, then you can have this form. Let me demonstrate that. Okay, but first of all, I want to fix the wording here. Okay, so let me show you two different wordings. So this is what we want to do. Array of dimension that using elements in list one. No, okay, so that's a mistake. There's no list one. So delete that. Go back to browser. Look here. Refresh. Okay, that's better. Yeah, okay, so let's do that. All possible array 2 by 2. Okay, so let's start to do this example. Okay, so comment return all possible 2 by 2 array. Okay, that's what this means. Yeah, so let's run it. Okay, basically the same thing as here. So so let's try. You see, the goal is to make the tutorial as clear as possible. So can we try a one by one array? So what does it mean 1 by 1? Yeah, that still makes sense. Actually, you can do it like that. Yeah, that's just one item. Okay, so 1 by 2. So this is a, let's see if I can. So this is 1 by 2. Does that make sense? I'm not sure. So, but 2 by 1. Let's just do some examples. So again, they are all possible tuples. Now a tuple of one item doesn't make sense. That's why you got these, braces, single item A and B. Yeah, that doesn't make sense. So you don't want, let's see. Yeah, this doesn't, I mean, logically it still makes sense. You get a tuple of 1 by, just 1 by a dimensional 1 matrix, basically. Yeah, okay, let's remove it because we got other things to do. So let me think. Does that make sense? Okay, so C, tuples AB 2 by 1. So 2 by 1, yeah, that doesn't make sense. Whenever you have 1, that's not making a lot of sense. Now this is tuples 2 by 2. Yeah, so you see, look at this single item. That is a matrix, two-dimensional matrix. It's a 2 by 2 matrix. Here's another matrix, 2 by 2 matrix. Here's another one. So basically this returns all possible 2 by 2 matrix of involving elements A and B. So let's write it. Yeah. Yeah, so actually that makes sense. Okay. So if we say, let's say 2 by 2 by 3, can you actually do that? Yes, we can do that, but it's gonna be long result. Yeah, this is, exponential growth. Oh my god, this is like thousands of items. Okay, we don't want that. Yeah. Delete. So what about 2 by 3? Okay, kind of hard to see. Okay, but you can, if you run this, right now we are running it in Emacs. Of course, you can run it in Wolfram Notebook. Shift Enter to evaluate it, so you get prettier output. See, okay. So let's not do this too long. Okay. Delete. Okay, put it back. Put it back. Syntax correct. Showing browser. So you got tuples, and we just demonstrated all possible arrays. Okay. Okay, so this one is done. Array depth. Okay, let me talk about this. What does it mean? What does dimension means and array depth? Okay, so that would be let me go to it. So subset subsequence it's fascinating. Okay, so that's why part of the reason I recommend Wolfram language, because in Python, in whatever language, Golang or even Haskell, F#, they don't have these functions. Even if you, most of the time, even including all the standard libraries, they don't have these functions. So this combinatorics, you know, for example, you have permutations or possible permutations or possible n tuples. Then you have, you know, you have several forms. This one does Cartesian product, okay? And so then you have subsets or possible subsets of a set, and or possible subsequences. You know, they are kind of tricky, you know, so these are all combinatoric stuff, and all possible groupings. There's something I need to do here. So anyway, but let me go to this part. I want to so go to list operations and go to the list concept, the array and dimensions. Okay, so here we talk about what does dimension mean. Dimension just means basically the shape of the list or the shape of the n-dimensional matrix. Okay, like if we have a 2x2 matrix, that's a 2-dimensional matrix because you got 2 and by 2. And the shape is 2 and 2. You use 2 numbers. So in the first level, you got 2 elements. In the second nested level, you got 2 elements each. So that's why 2x2 matrix. Then you can have 2x3 matrix or 3x2 matrix or 2x2x2 or 2x2x3. So this sequence of numbers is called dimensions in Wolfram language. Okay. You can see, so you got the 2x2 matrix here, so the dimensions is 2, 2. Now here you got a simple flat list. The dimension is just 3 because it only have one dimension and it has 3 elements. So that's what dimensions means. So, but what I want to do, array depth. Okay, so array. So what I want to do is add an example for array depth. Array depth just means the dimension of the array. Okay, so if you have 3x3 matrix, that's a 2-dimensional matrix because you require 2 numbers to specify. So if you have 3x3x2 matrix, that's 3-dimensional because it requires 3 numbers. Okay, so in other words, array depth just return the length of dimensions, but let's add an example. Where is it? We're still on this page. So copy the file path, close that. Okay, paste the link here, go to it, search for depth. Okay, array depth. So that's dimensions, search. So you gotta go to the depth here. Okay, so Wolfram language, put it up. So array depth. Okay, then let's say AB. So AB and CD. Okay, that will return 2 because it's two-dimensional matrix. Okay, so and you can say ABC that is ABC D E F. That's a 2 by 3 matrix. That dimension is still 2. So what if you want a 2 by, let's say 2 by 2 by 2 matrix? Okay, so let's generate it. Okay, so 2 by 2 by 2 matrix. Okay, let's say F X, Y, Z. Okay, X goes from 1 to 2. Y goes from 1 to 2. Z goes from 1 to 2. Okay, so do it. That will return 2 by 2 by 2. So let's clarify. Okay, so you can see this is does that make sense? Okay, so what are we doing? So we are generating a 2 by 2 by 2 matrix. So if you say dimensions of this thing, that will return 2 to 2. Run it. There it is. Okay, so and if you say array depth, that will say 3. There it is. Okay, so because there are 3 numbers here, so does that make sense? This is a bit complicated example. I'm not happy with it exactly, but again, the goal is to make this as simple as possible so people can understand. So here we have dimension 2, 2. Yeah, let's get the dimension into place so it's easier for people to understand. Okay. Dimensions 2, 2. Array depth 2. Okay, and here let's get dimensions. Okay, dimensions that would be 2, 3. Okay, and then let's put a breaker there. Okay, so dimensions 2 by 3 matrix is 2, 3. So comment 2 by 3 matrix. When you have English comment, actually that makes it easier to understand. So that's one of the problem of programmers or hackers writing a tutorial, because to me it's so obvious, like dimension, this just means the dimension 2, 3, but to other people not really. So but if you say 2 by 3 matrix, people will get it. Similarly, for a lot of other programmers, they write tutorials or blogs about Haskell, about functional programming, or about or C++ coders. To them, is something is obvious, but actually not really. Okay, so you show the dimension 2 by 3 matrix. The dimension is 2, 3. It becomes so obvious. Then dimension of that is 2. So in here, let's also add a comment 2 by 2 matrix. Okay, so what about this one? This is this is like a 3 by 3 matrix. I mean 2 by 2 by 2 matrix. Okay, let's see, let's make a comment. Create a 2 by 2 by 2 matrix. Okay, then dimension 222, array depth 3. Okay, I think that's clear. Put it back, syntax correct, showing browser. So we explained here array depth. Same as length, so typically known as the dimension of a array. Okay, better, is it better? Yes, I think so. So okay, now update the updated date. Okay, this part is done. Add example, close it. Now level spec, that's another very interesting thing. Okay, level spec. Okay, so let's do level spec. So that's that will be level. Okay, now let me explain this, because this is a very powerful and interesting idea. Okay, so if you have a nested list, basically that list can be represented as a tree. For example, 1, 2, 3, a flat list, you can represent it as a tree like that, you know, where the you know, a tree of 3 leaves or 3 branches. Now if you have 1, 2, then nested list AB, then you have this tree. So whenever you have a nested list or even any nested expression, you can view it as a tree, and once you view it as a tree, you have the concept of depth. So for example, these items 1, 2, and list, they are at depth 1, and this A and B, they are at depth 2. So this, the root, you consider level 0. So then below it is level 1, then below it is level 3. And if any item, if any node, they do not have any children, then you think of them as leaves. So this 1, 2, and AB are leaves. Okay, so you have the concept of depth. Now when you count, so and you give a number to each depth, and in Wolfram language that's called level. Okay, that's called level. So this concept is very powerful, because in any function that applies to, that takes an argument of a list, you can specify the level, so that function will only apply to those nodes. You know, so that's the general idea. That is why we have this level concept in Wolfram language. Okay, so for example, let me just run this in Wolfram language, so you can kind of see interactive. Paste it here, run it, so you see. So now, and in this case, the list is basically a, sometimes they call jagged array. It's a nested list, but in each level they don't have the same number of elements. If in each level they have the same number of elements, then we call it rectangular array, like we were doing before, like the, you know, dimensions and, you know, but and matrix, n-dimensional matrix, where at each level you have the same number of nodes. But in this case, you have a nested list. However, in each level, they don't have the same number of items. So sometimes they call that jagged array in C or Java. So in Wolfram language, so here is Wolfram language, you can see this tree representation, okay? And that makes it clear. So these things are level 1, these things are level 2, and these things are level 3. Okay, so but what is it I want to do? So here I want to change the name. Okay, so let's see. Level Spec. I think by the Wolfram language official documentation, do they call level spec or do they call it level specification? Yeah, level spec, you can see. Yeah, they just call it level spec. So I'm wondering if I should call it level specification, because spec is really short for specification. Nah, let's just follow their way, okay? So, but add, add spec depth. Should I say that? So level spec is a standard form in Wolfram language to specify a specific level of an expression or a range of levels, m to n. Okay, yeah, that okay. I'll leave that. So does that make sense? So if we run an example, it will be much clearer. So let's do that. So, but here I want to change wording. Okay. Example. So map a function to a level. Okay, something like that. That's more clear. Okay, so does that make sense? Okay, hold on. Map. Okay, so delete that. Okay, I think I'll just leave it there. So okay, so but let me run this so that you guys can see what's going on. So for example, yeah, so how do I, so what should I do? So well, in order to explain this, wait, you need to be Wolfram language. So Wolfram language, completion, tree form, okay, tree form at, okay, when you see this in tree form, it'll be much clearer. Okay, so we got a list like that, A, then B, then CD, okay, like that. So if you map to level 1, it will map to A and this list, okay. So for example, so yeah, so now you need to map, okay. So let's show this example, okay. So this means map F to level 1, and if you show this in tree form, // tree form, / is a postfix notation. Okay, wait, I didn't type it. Run it. So you can see F there, that's our function, is applied to A and list because they are at level 1. You see, level 1, A and this list. So you see F applied to A and list. then the rest, and the output looks like that. Okay, you see F and F. Okay, so that's the idea. So I'm not going to run the rest of it. Okay, but maybe I should copy this and paste it here so it's clear. So anyway, next. Now pattern matching. The relation of pattern matching and level spec. This is another very interesting one. Okay, so let's go to that. So close that, and maybe that's about it. How many more pages? A few more pages. Okay, yeah, okay. Level spec, and now I want to do pattern matching. Level spec is critical in matching nested pattern. Yes. So here, that's the page I want to do. Okay, close it. Paste that. Go paste listify. Go to the link and update the page. Pattern matching and level spec. Okay, first of all, let me just fix a few things. So change the wording, depth level of a tree, specify depth level of expression for pattern matching. Okay, so what I want to say is specify depth level of expression. Okay, depth level of expression for pattern matching. Okay, so that's more verbose and that's more clear exactly what we are doing. So so delete that. Okay, so that's that. Delete that, and let me change this. So, and then I'll explain it. Okay, X, Y. Okay, so then we need Y match 4. Okay, copy, paste, and here Y match 2, and here here is, yeah, wait, so it can match any of, yeah, so here X match 1, Y matches okay, so what's going on is that when you do pattern matching, you can specify what level to match, because if you have a pattern such as this one, you know, braces and X, Y, what that means, the underscore means any expression, and once it match, you give it a name X. Okay, so that's what it means. That, you know, so basically this matches a list of any 2 items. Okay, now however, now if your expression is this will match in several ways, because the X can match the first item 1, and the Y can match the second, you know, nested list. Okay, but it can also, you know, go match this part. If you match this part, X is 2, Y is the 3, 4. And it can also match just the innermost list. You know, X is 3, Y is 4. Okay, so there's this. So depending on what level or what depth you want to match first, it can match in several ways. So therefore, Wolfram language provide a way in many pattern matching functions. It allows you to say allow you to specify a level spec, just like the map we did before. So that's what this page is about. So this is about the importance of understanding the level spec. Okay. So so did I get this right? It can match any of that x match 3, y match 4, or that x match 2, y match 3, 4, right? Or that, yeah. Okay, so that's what I want to do there. Okay, delete that. Okay, now here is example. Let me demonstrate that example. Anyone else watching? Any comments? So let me demonstrate some examples. There are a few things I want to fix here. So yeah, so okay, replace on side that. An important aspect of pattern matching is at what depth. Okay, let's remove the name tree because tree might be confusing with a graph tree data structure. So let's just remove tree depth. Oh, and this specify, this means, let's remove that. Delete that. Okay, so this is the last thing we're gonna do, and that's it for today. So this is the last thing I wanna do. So we're gonna do, move that to bottom and show tree form. That's it. Okay, so let me just prepare first, then I'm gonna show you. Okay, so cut. Okay, then let's do that. Okay, and we also want to show tree form. So what we're gonna do, so if we can run it, for example, here is an example. You got this nested expression with kind of tails, and you give the pattern x and y blank. That means match anything. Once it matched, you name it x. The match part is x, and the other part is named y. Arbitrary name. You can say anything. Okay, so then you replace, once you match it, you replace by this symbolic expression gxy. Okay, and the last argument here is the level spec. So this bracket 1 means at level 1. So that means at level 1 you just got, you got this thing 1, and this list is level 1 nodes. So this pattern we will never actually see. It will never directly match that 3.4. So that's why so the result is going to be like that. You see the level 1. Oh yeah, so level 1. Yeah, so level 1 is actually, so level 1, this number 1 is on level 1. Does it match this pair? No. So that's why that doesn't change. Okay. And let's magnify. Okay. Now, this expression is also on level 1. Does it match the xy? Yes. You got 2 and then the 3, 4 thing. Therefore, that becomes that. Okay, but I want to show an example, match level 0. Okay, so match level 0. Okay, so run it. In that case, you'll just get, you see G1 and that. Okay, so that makes sense. Match level is, level 0 is basically the entire thing. Okay, so does that make sense? Any comments? Good so far, fantastic. Do you take those notes using some sort of tablet? Yes. We basically, we are done. Okay, so so this is still not satisfactory. Okay, but basically, let me answer the question in a bit. Okay, so basically this page, what I want to do is basically done. And I mean, not done, I wanted to generate the tree. I want to generate this graph for each example of the level so that people can easily understand. But for this video, maybe that's it for today. Okay, so let's see. Yeah, so the tablet, the one I use. So you search for Xah keyboard blog and search keyboard and search for Surface, Microsoft Surface Pro. That's what I have. Okay, so actually I did a review, kind of showed it 3 years ago or 4 years ago, like 4 years ago. So I got this. By now it's like 8 years old, but it so happens it's still useful. So it's quite good. So Microsoft Surface Pro 4, this is from 2018, before actually 2015. So by now it's 10 years old, but I still use it every day. So I just take it, walk around, and write notes. So that's what that's the notes you are seeing. Okay, and then let's see. Sorry, I don't understand anything about Wolfram. It's quite late here. I'd like to see you talk someday about what you think of creating blogs with Hugo and Emacs Xah Mode. That's a funny question because a lot of people try to tell me to use that. And basically, my opinion will be disappointing to you because my opinion is I don't use those Hugo or Xah Mode because I code HTML raw. Actually, I talked about this many times. So if you look at my older videos, you will see a lot. Basically, by now I have like 300 was it 300 or 400? Wait, 700. Today's talk show. Okay, so Level Spec, close show. Today's talk show, episode 713. So I have 700 videos, and every one of them is you are watching me doing raw HTML. Why do I code raw HTML? For example, I can delete the entire thing or delete the entire header, just one keystroke, smart delete, undo, or so a lot. So I demonstrated lots of it. You just look at my videos, search for Emacs HTML, search for my name, YouTube. Okay. So why do I do it raw? Because I was, I watched the birth of HTML in 1992. Basically, 1992 is when I began to use it. That's basically when HTML began. And I watched the birth of CSS. I watched the birth of JavaScript. So CSS. So in the beginning, I write my HTML character by character, like, like press. Actually, oh wow, today it's so advanced. You can't even type. You can't even You can't even type a single. Let's see. So new buffer, switch to text mode. Now you can type. So you type HTML, close it, then you basically type again, then close it, then you press like that, character by character in starting in 1995. That's how I began. And in the beginning, I typed them in Microsoft Word using Microsoft Word macros, because back then I read the entirety of Microsoft Word manual, and it's actually one of the best software, Microsoft Word, in the 1990s. Okay, and lots of features. So I read the entire manual. So that's how I begin HTML. So, and by now it's 30 years coding HTML. I don't I don't type them character by character, of course. For example, I can just something, press a key, it becomes that, or just delete it, or you can move the cursor here, delete that, or you can select more, select more, select more, select the more, and select the entire main. You see, go to the bottom, you see. So, and I'm using Xah HTML mode, which I wrote in the past 10 years. So describe key, press, see the documentation, Xah HTML mode, and you got these like 50 commands. So go to the source code. There's actually several files. So Xah HTML. So let's highlight all files with Xah HTML. So there's about 7 files. Okay, something like 10,000 lines of code. So by now I'm, I use, my own HTML mode, but basically still everything I do is manual. Okay, so, and for those people using org mod, I am more efficient even when I code raw HTML, because you can count keystrokes. You count the keystrokes when you want a list, when you want a footer or whatever, when you want a H1 header, or you can compare doing that in org mode, the number of keystrokes you type to create the same thing. I would say my way is actually more efficient, less keystrokes. And then I don't have to generate it. Like when you generate from org mod, usually there's lots of bloat. And I have more control, and I also manually code my CSS. There's no framework, no nothing. Okay, well, because I watched the birth of them, and I'm a nerd. So, but for you can do the way I do. You could, but the price you have to pay is that you need to be a nerd. You need to be obsessive in studying HTML and in studying CSS. Okay, so let me just show you quickly. So for example, and also JavaScript. Okay, so go to the tutorial, programming tutorial. So you need to master HTML. Okay, master, like you can start with my tutorial, and you need to master CSS. Okay, so you know exactly what they are. No framework. Like today's people, they use frameworks. They have no idea what's going on. They just read the framework documentation. And, that's not necessarily a bad thing. But if you know this stuff raw, that gives you the power. That actually makes you a real software engineer, because those framework writers, may it be CSS, or may it be HTML framework writers, or may it be JavaScript framework such as React, Vue, they need to know like what I know. They need to know the real fundamentals. Then they can write those frameworks. So for you, if you are young, you could start with frameworks, but if you learn the raw technology, that gives you a lot of power, because then you don't need, then either you can continue to use those frameworks, very useful, especially if you work in a corporation. It's almost necessary, but then you do understand what's going on beneath, so that gives you a lot power that makes your craft much better. Okay, so why do I not use Hugo or Emacs Xah Mod? Because I don't need to. In fact, Hugo, I would tell the creator of a Hugo to use my system. It's more efficient than Hugo. Okay, I think that's it. I was able to execute the last example in Emacs with Xah Wolfram Mode. Thank you so much. Fantastic. Thank you. Xah watched the birth of the Linux fuckheads. That's true too. Linux was born in the 1990s. It became kind of public around 1996 something. I mean, even 1996, like only nerds know. Okay, actually, it's up until 1999 with Apache. They started to have some public awareness. Linux. Okay. So anyway, that's it. Thank you, guys. If you like my stuff, donate to me. Okay. Just go to, check out my tutorial, JavaScript tutorial. You can buy the whole thing on a zip file. I send it to you, $35, a token of donation. I don't make money, nobody buys it. But if you want it, I give you the entire JavaScript tutorial in a zip file, so you can read it on your computer. And similarly for my Emacs Lisp and Emacs tutorial, and then I got lots of other tutorials you can check out. And so go to the homepage, xahli.info, Xah code, no S in HTTPS. Okay, then go down, then you can Patreon me, Amazon gift card me, and PayPal me. Okay, thank you guys. Bye. So we shut down in 1 minute. So yeah, I'm just gonna do this offline. That's basically today. I like simpler websites without all those modern features, but I don't have much time to learn HTML and CSS. Well, what do you mean? Because looks like you are a young guy. So if you are a young guy, you have plenty of time. Unless you already work for a corporation. I mean, but you do, okay, so the bottom line is it's up to you. Okay, it's not really necessary for everyone to know the details of HTML. Actually, you need, because are you a web developer? Are you a professional web developer? Okay, if you are, and if you plan to be professional web developer for the next, let's say, 5 years, then it is absolutely necessary to know the full detail of everything about HTML and CSS. Okay, like today's Zoomer generation, I don't understand. They have the idea. They don't even, they don't want to or don't have time to learn the fundamentals of CSS. What are you talking about? So if you plan to be the web developer, a good one, a professional one, of course, you make money, but you want to be a good one for the next 5 years, you have to, okay, know all the gritty details of CSS and HTML. Okay, it's not optional. But however, if you are just, if you are in it for the money, you work for a corporation, so you are a professional web dev, but you don't actually care. You don't actually care about, the technical details. The framework changes every month. You don't really care. Okay, but you can make money, like those corporations. In that case, you don't really need to know. Okay, or your heart is somewhere else. You are into machine learning. You are into mathematics. You are into to become an engineer in chemistry, organic chemistry, or inorganic material science, or whatever. Your heart is not doing web dev. In that case, yeah, you don't have to spend too much. You don't have to. Framework works, it works. Okay. So here's I need a job first. Haha, I'm not professional, just a hobbyist. I'm more interested in cybersecurity. Okay. Well, in that case, you need to know this to get a job, you know, because when you look for a job, you know, if you know, they care less about, you know, you need to know frameworks, but the people who know frameworks, they are a dime a dozen. Okay, they are cheap, like they are like they are not quality. A dime a dozen. Everyone knows frameworks. But if you ask them how does it work exactly, how does let's say React actually work, can you write it? Can you write recreate React, the fundamentals, or do you even know the basic concept? What is it doing exactly? If you during an interview, if you like tell the guy, oh yeah, I don't know React, but I can tell you how to write it in 10 minutes. Let me demo. Okay, they hire you. They hire you right away. Okay, bye.